All right, exam number 3 review. So, welcome students. This is my review for our 3rd exam. I will remind you that there are 3 of these exams during the course of the semester, and we drop the lowest score from these 3 exams. Our 3rd exam is going to cover chapters 7, 8, and 10. And what I want to do tonight is to let people know exactly what it is we need from these sections. Chapter 8 in particular needs probably the most focus. 7 and 10 are relatively short and focused as they are. So, chapter 7, that was our confidence intervals. All right, so I'll remind people that's where we estimate a population parameter with a sample. We look at 2 specifically different cases. 7.1, we work with population proportions. And in 7.2, we work with population means. So let me go ahead and begin with the 7.1 material. So there's a lot of detail in some of these sections, formulas and the like. I will remind people as I go through my review what tools we use, specifically what TI-84 tools we use. So estimating a proportion. We start with the sample, and that gives us the point estimate. That point estimate is p hat x over n. And then we select a level of significance, that's R alpha. And we have the margin of error. And that margin of error depends on that level of significance. And it looks like E equals Z alpha over 2. And we got P hat, Q hat all over the square root of n, all within a radical. And I have that formula there because it's one of the few formulas you may be required to actually use during your quiz. Given data, a point estimate, and a margin of error alpha, I can ask students to go ahead and find this margin of error. I will note that the point estimate gives us P hat and Q hat. I should note that Q hat is 1 minus P hat, oh, as well as N. And then the alpha is what gives us the critical value, plus or minus. And I'll remind people that we use the inverse norm to get at that critical value. I need a level of significance and to work with the inverse norm. So I may ask you to find the margin of error. And once we do that, I can also then ask people to build confidence interval. Now that confidence interval is p hat plus or minus that margin of error, but I don't want to use that formula. I'll use one prop z interval to actually do that. It's kind of nice. All I need to give it is I need to give it x and then the level of confidence. And that level of confidence is excuse me, it's 1 minus alpha. Almost always it's 90, 95%, and 99%, although you could see other values. Should be fairly straightforward. So the first things I can ask students to do is to work with the particular formula to find the margin of error, but I can also have students use a given confidence interval to find p hat and e. For example, you might have a level of confidence as 0.04 less than p less than 0.12, and I can ask people to go ahead then and find that point estimate. I'm going to hold off on doing that. I've already done a number of these examples, and as I say, tonight what I'd like to be able to do is just to run through the basics that we're going to need from all our 3 chapters. And then I'll get into specifics tomorrow. So you should be able to go ahead and, given a confidence interval, you should be able to find the point estimate and the margin of error. The other things I can ask you to do, there was one other skill in there, and that was the sample size. So the sample size, that's where we use a given margin of error and level of confidence. There were 2 formulas, z alpha over 2 squared times 0.25 divided by e squared, or n equals z alpha over 2 squared times p times q all over e squared. This is for when we have no detail on p and q, and this is where we have some previous detail. You have to read the problem carefully, but as I say, we have to give you the margin of error, e, and we have to give you the level of confidence, and that level of confidence gets us the critical value, z alpha over 2, again, using that inverse norm tool. So that inverse norm tool, there and there. Goes in just like it looks. Keystrokes are usually not an issue. There is one other issue, though, with this particular problem. If n does not come out to be a whole number, and it usually doesn't, the rounding rule is to round n up. Round n up. And that's a very important rule. If we round down, we won't have quite the level of accuracy we desire. So that's the material that comes out of section 7.1. Section 7.2. Estimating population means. We have our point estimate. comes to us from our sample, X bar. And we have a margin of error, E equals T alpha over 2 S over the square root of N. And we use the T distribution here, not the Z distribution. And we can also ask you to find the margin of error in this case. Inverse T finds us that critical value. We have a degree of freedom equals to n minus 1 in this particular circumstance with the T distribution. But at the end of the day, that's really what what we have. The other thing that that I want students to be able to do in this particular section, it's much harder in 7.1. It's very easy in 7.2. I would like students to be able to check the requirements for constructing a confidence interval. There's only two of them. We need a simple random sample. There's one. And then either or, either one, the other, or both, n greater than 30, or a normal population. So the way that shakes out, to make sure everyone understands how those requirements go, if n is greater than 30, if that's the case, then go ahead and you construct confidence interval as long as we have a simple random sample. If n is less than or equal to 30, we need one of those simple random samples again, and we must check for a normal distribution on the variable in question. And that's if n is less than 30, and less than or equal to 30. So I'd like students to be able to check you should be able to build or construct the confidence interval. That's the X bar. No, that's horrible. Penmanship. That can't stand. So build the confidence interval. That's the X bar plus or minus that margin of error. And we'll use T interval on your calculator. Now, the one little twist here in this particular section is the T interval tool can be used with summary statistics. That's the X bar, the S, and the N, or raw data. That's where you'll have your sample in list 1, and you direct your tool to list 1. So that's really pretty much it as far as the 7.2 material goes. I will note that in section 7.2, there will be no questions from 7.2 on sample size. You'll note that there is a formula but I haven't discussed it and I don't use it. I really restrict my sample size issues to section 7.1. So there's your chapter 7. Chapter 8, hypothesis testing. All right. This one was a little bit more choppy in terms of presentation because they were our author really tried to convey the totality of anything you might encounter in a hypothesis test anywhere in chapter 8. All the little bits and pieces are all sort of there together in 8.1. And I'm not sure that really works well. But having said that, there are some things that I need to have you do that really are introduced in section 8.1, although they can appear in later sections too. So from 8.1, you should be able to write the null and the alternative hypothesis. You should be able to know that the alternative hypothesis never contains equality, while the null hypothesis always, always, excuse me, contains equality. From 8.1, I can ask you to find the test statistic for the two tests in question. I'm going to put the formulas in here. Those are the two we use. You really truly encounter these when you look at 8.2 and 8.3, but they are introduced in 8.1. So if I give you sample data and claim data, you should be able to plug it into these particular formulas and have at it. I will say that this one here is particularly important in terms of incorporating grouping symbols for the denominator. I can also ask you to find the p-value. And to find the p-value, you need the null hypothesis and the test statistic. That was where we had to plot the test statistic on the distribution and calculate that area. That area is equal to the p-value. And we use the normal CDF tool to get that area, just like we used it in 6.1. It'll be a z-score, so it's the z distribution. That's really what I need to have you take from 8.1. Oh, one other thing from 8.1. You should be able to also identify the type 1 error. I have to give you a claim so you can develop the null and the alternative hypothesis. And that was where we needed that decision matrix where we had the outcome reject and fail to reject the null hypothesis. Null hypothesis might be true or it might be false. This was the type 1 error, and this was the type 2 error. These guys here, the outcome was appropriate to reality, and the test was right. I will remind people that the type 1 error is to reject a true null hypothesis. That's what the type 1 error might be, or is. So that's really what I have to have students be able to do from the 8.1 material. 8.2. Claims about a proportion. So this is where we'll use the one prop z test, not interval, z test. And I'll use that with that p-value method. I'll remind you that for the p-value method, if p is less than or equal to alpha, we will reject our null hypothesis. And if p is greater than alpha, it is a fail to reject that null hypothesis. So claims about a proportion handled with the p-value. A couple of things I'll want to remind people. There are really 5 steps, and I can ask you to demonstrate any one of the 5 steps. So you need to be able to write H0 and H1, find the p-value, compare with the level of significance alpha, determine the outcome, and then you need to address that initial claim. So 1, 2, 3, 4, 5. So I can ask you to demonstrate any one of those, or even all 5, I suppose, within a single problem. But you'll need to be able to do that. And again, the p-value is super important. We essentially handle all our tests for statistics using a p-value approach. That's the way the big boys and girls do it, so that's the way we'll do it here. And that's really the detail there. I will note that if we change alpha, we might change the outcome. If alpha, say, drops from 5% to 1%, it's possible the p-value could then end up being greater than alpha when alpha was 1%, less than or equal to alpha when alpha was 5%. So if we change alpha, we might actually change the outcome. There we go. Hmm. 8.3. Claims about a proportion. T-test with the p-value. And we can use it with summary statistics, or we can use it with raw sample data. Just like 7.2. We do have the requirements. I can ask students to check the requirements. And those requirements are the same as in 7.2 when we were estimating a population mean. Excuse me. So same 2 basic requirements, simple random sample and either n greater than 30 or if n isn't greater than 30, you want to make sure you've got a normal distribution. I don't set people up for failure on this problem, so we all always try to keep it all copacetic. And that's really truly about it for 8.3. Again, you got the same 5 steps. I won't write them again. I've written them a whole bunch, so they're still there. You need to be able to remember to check the initial claim. And again, if you do change alpha, it's possible the outcome might change. 10.1, correlation. Scatter plots. I'll ask you to draw a scatter plot. So we can take a look at our bivariate XY data. And then we can test for correlation. And that is actually the alternative hypothesis. Test for correlation. That is the alternative hypothesis, rho not equal to 0. The two hypotheses, rho equals 0 means there's no correlation. Rho is not equal to 0, which means there's a useful correlation. There are some super ugly formulas in there. I will remind people that it is the sample statistic R, which which falls between -1 and +1. At -1, it's a negative correlation and things go downhill. At the +1 side, it's a positive correlation and things go uphill. The correlation gets better and tighter the closer that R gets to either a positive or a -1. And I'll note that if R happens to be a positive or a -1, you are now back in your algebra class graphing y equals mx plus b for all intents and purposes. So how do we handle all of this? For the scatter plot, we use that stat plot with list 1 and list 2 for x and y, and under the zoom key, number 9, zoom stat, and brings up the correct picture. So there we go. That's our scatter plot. For the test, linear regression t-test. And it's down near the bottom. And you'll have to point it at list 1 for your x and list 2 for your y. You always want to make sure that it is a rho not equal to 0 for the alternative hypothesis. There's a beta in there, just ignore it. So you just point it there. There's also a little place for the quote-unquote regression equation. Just leave it blank. And you're going to use this with a p-value approach. If we reject the null hypothesis, we're good to go and begin the good work in section 10.2, where we have the regression equation. Thank you. So y hat equals b naught plus b1x on the TI-84. Linear regression t-test gives us, excuse me, y equals a plus bx, which matches up very nicely with the regression equation developed from our sample. And the y-intercept, beta naught, the slope, sorry, not beta naught, b naught, and the slope is b1. Just to note, b naught is the y-intercept, b1 is the slope. I will ask you to round to 1 decimal place when you're working through one of these types of problems, and then we'll go ahead and use it given an x. Y hat equals, and you plug it in, you'll find the predicted value. There are some requirements here. They are rather stiff. I usually just have students handle the nuts and bolts of the test and the regression equation. This is all linear regression. There's other kinds of regression out there. Linear regression, though, is the most basic, and it's the very nice place to start. And it is truly used an awful lot in the land of statistics. So that's pretty much what you're going to see and what I'm going to ask you to do for this particular data in the chapter 10 material. You also now see what I'm going to ask you guys to do in the chapter 7 and 8 material too. So that pretty much wraps up my review of the topics that you're going to encounter on this third exam. Tomorrow night, I'm going to run through specific examples from all of these. So come back tomorrow night and take a look at some specific examples. I'm going to go ahead and post as I usually do, so look for some videos in the Canvas course cell. I'm going to stop recording now, and I'll thank you for your attention. Thank you for your attention.